So today we are transitioning from working with expressions to now working with equations, and we're being asked to now solve them. So like I was saying at the beginning of class when Chris asked, yes, when there is an equal sign, they're going to ask you to actually solve for x. So we're going to incorporate what we learned the first 2 days of this unit to help us now solve these equations. All right, so there are technically 4 different types of equations that you're going to see. Okay, the first type is just a plain rational set equal to either a whole number or another rational. Now, before we actually start solving this, let's take a look at it. We need to recognize first what values of x can this equation not have. Why can it not have 2?
Because it would mess up the fraction.
How would it mess it up?
It wouldn't be able to do its thing.
Why not? What's wrong? If we have a positive, you can never divide by 0, right? As soon as we try to divide by 0, it becomes undefined. So here, what values of x cannot be part of the equation? X cannot be a positive 2. And why or why not? Because it makes the equation undefined. So therefore, x equals 2 is a value that x cannot take. That makes the equation undefined. Now, if when you're solving this equation, you happen to get a solution that is this number, so say we're solving this and we get maybe x equals 2 and also x equals 4. That x equals 2 solution is now called an extraneous solution, meaning it can't work. You can't have it. It's not a real solution. It is extraneous. Okay? So you can put here extraneous. So that's why we have to check for what makes the function or the equation undefined. Is because sometimes we'll end up with a couple solutions and one of them will be that undefined number and we have to say, no, that's not a real solution, it's extraneous. All right, so now let's go ahead and start solving. We have 3 over x minus 2 equals 5. Now, how do you think we're going to solve this? Yes, why are we multiplying by x minus 2?
Because we have to get it out from underneath.
Yeah, we got to get it out of the denominator, right? So we're going to multiply both sides by x minus 2. And here the x minus 2's cancel. So we're just left with 3 set equal to. Now, do you think I want to leave this in factored form like that, or do you think I want it back in standard form? Right, we're trying to actually solve for x now. So I need to distribute the 5. Now I did see this on some quizzes. Even though we talked about distributing, still people are confused by this concept. Do you just multiply 5 times x and then put this? No, that is so wrong, right? That means that you're only thinking, okay, 5 is just multiplied by x and the negative 2 is just there. No, you also have to multiply the 5 times the negative 2 and you get? Beautiful. Now what?
You add 10 over.
Right, you just finished solving, right? Add 10 over. We get 13 is equal to 5x. This is an ugly one, but it's okay. Divide by both sides by 5. And x is 13 fifths.
So that would be our pizza number?
Right. Is this a number that would make our equation undefined?
No.
No, right? The only thing we had to worry about was 2. So this is a reasonable solution. So here in reasonable, we put x equals 13/5. And there are no extraneous.
How would you get more than one? So if there's more than one solution?
If it's a quadratic.
Oh.
Yeah. Also, I want us to analyze this a little bit. What was another way that we could have solved this? That may or may not have been harder or easier depending on what you're comfortable with. Another way to think of doing this problem. Right. So look, we finally have a rational set equal to something. What did I say you can do when you have it set equal?
You can cross them.
Oh, you can finally cross multiply. So that 5 is actually over an invisible what?
1.
1. So you're cross multiplying here. It's just 3 equals 5x minus 25. Oh, wait, what did I do? Oh, that was a 2. I'm like, that 25 was not in our problem.
No.
Right? And it's the same thing. Same exact concept. All right. So now, moving on to number 2 down here. What values of x cannot be part of the equation?
-4 and -3.
So, say I put -4 in for x. Does that make either of my rationals undefined?
Makes one of them.
So, say I put -4 in for x, right? It would be -4 minus 4, which is -8, divided by 4, which is -2. Is that undefined? No. What about -4 divided by 3? Is that undefined? No. So if I did +4, what is 4 minus 4? What's 0 divided by 4? 0. It's not undefined. This one trips everyone up. You think just because I ask you what makes it undefined, there has to be something. Is there an x in the denominator? No. So is there any value that would make this equation undefined? No. There's nothing. It's okay. You can have nothing. You can have nothing. There has to be an x in the denominator for you to start worrying about the undefined, okay? So there is no x in the denominator, we're okay. So technically, these aren't even rational functions, right? They don't even have x's in the denominator. That's the key that makes a rational irrational. But we'll go with it. All right. So, well, why or why not? Let's put why not. So we do not have something that makes this undefined because there are no x's, no variables in the denominator. All right, so let us start solving now. What do you think I'm going to have to do first here? I have to deal with this left-hand side where I have I have two expressions added together, two terms added together, right? So I need to first combine those before I deal with the actual equation and solving. So how do I add two fractions together? You have to get a common denominator, just like we did last class, right? So do 4 and 3, do they have a common factor? No, they don't. So what is it's called the least common multiple. What am I going to have to do? Multiply them by each other. So we get a least common multiple of 12, right?
Yeah.
So we multiply this side times 3 and this side times 4. Now, in the top, what should I do? Distribute, yes. So we have 3x minus 12 plus 4x over 12. Now this is addition, so it's pretty straightforward. So I just combine my like terms in the numerator. And what do I end up with? Yeah, 7x minus 12 over 12 equals 6. So all I did just then was I combine the numerator. The denominators, remember, when you're adding fractions, you just add the numerators, you keep the denominator the same. Okay, so now what do we do? So what do you say? Yes. Now, I'm glad you guys didn't, but in first period, they were like, okay, can't you cancel out those 12s?
No.
No, right? Why can you not cancel those 12s? Ah, you have 7x minus 12. That's not multiplication there. You cannot cancel the 12s. So, yes, just like you guys said, we're going to multiply both sides by 12 to, oh, what happened to my equal sign? To get rid of the 12 in the denominator. So we're left with 7x minus 12 equals, what's 6 times 12? 72. And then we add 12 to both sides. And we get divided by 7? Yes. Is that a restriction we had to worry about, that number? No, right? We didn't have any that would make it undefined. So that is our reasonable solution, x equals 12. There are no extraneous solutions. Is this making sense so far?
Yes.
Okay, good. Depending upon your viewpoint, we may be stepping it up a notch now. Not really, though. I don't think so. Okay. Number 3 here, which I wish it was numbered. Number 3. What are our restrictions? What would make this undefined? 0, right? We have to worry about when the denominator is 0. So when x is 0, then this would become undefined, right? So x cannot be 0. We don't have to say the why or why not again. We know why. And yes, x equals 0 is a value that x cannot take that makes the equation undefined. So let's try to solve this now. What do you think I must do first? Yes, I must deal with the left-hand side, combine those two fractions there. How do I do it?
Multiply by x.
Right, multiply the left times 4 and the right times x so that the denominators become the same. Okay, so now that the denominators are the same, what do we do? Yeah, you add the numerator, right? So can I add x plus 4 and get 4x? No. Ooh. I thought for sure everyone would be like, no. No, you cannot. Why? Ah, one's a variable, one's a constant. You can't combine unlike terms. So you just have x plus 4. Now what?
Multiply by x.
Okay. Right. We have a fraction or a rational set equal to a rational. How do we solve when we have an equal sign between two rationals? Cross multiply. Oh my gosh. So we have 4x times 3 and x times x plus 4. So 4x times 3, 12x, equals, this is going to be x squared plus 4x. I'm skipping the step where I show you that x is distributed to both. We understand this, right? Or don't we? Okay. Now what is the question?
12 over, so it's equal to 0.
Why are we setting equal to 0? Why are we factoring? What is the key here?
Find the x.
What is this now? Is it a linear? Oh, it's a quadratic. How do we solve quadratics? By factoring, by setting it equal to 0 and factoring. Good. So we're going to subtract 12x. Then what? How do I factor this?
Box.
Hold up. You could. Yes, you're right, Haley. You could complete the square like you're thinking. But what's the easiest thing to do here?
Pull out a x.
Oh my gosh, you can pull out an x, right? So we have x minus 8. So how many solutions do we have? 2, right? One where x is equal to 0 and the other where x is... Are both of these solutions reasonable solutions?
No,
Why are they not?
because x cannot equal 0.
Ah, this x equals 0 is extraneous. Right? We cannot have x equals 0, otherwise the equation is undefined. So this is 8 is our only reasonable solution, and 0 is our extraneous solution. Did I lose anybody? I do want to show you though, I showed you how to solve this way because when the problems get harder, this is just always the straightforward, easy way to go. But way back up here, when I had this, what else could I have done? Not x. If I multiplied this side by 4, what would that do? I would have x plus 4 over 4x equals 12 over x, 4x. And then what can you do here? What do you notice? The denominators are the same. So you can cancel them out and it's just x plus 4 equals 12. You see it? That's only when you can actually make the denominators the same. Most times the problems are harder than this and you can't do that, okay? That's why I didn't show you that way to begin with. Okay, so now for the last one. We're almost done. We're almost done. So, what values of x would make this undefined? Yeah, you can't have a positive 2 and you cannot have a negative 2. Both of these would make the equation undefined. All right, so let's go ahead and start doing this problem. All right, so how do we start?
You have to find a common denominator.
First, you want to subtract the left side, so you need a common denominator. So what am I going to multiply the left rational by? X minus 2. And the right one? Good. So I have x minus 2 over x minus 2 times x plus 2 minus, I need to distribute the 6. And I get 6x plus 12. Now what do I do? Right. Well, you just remember that when you're subtracting, you're applying the subtraction to both the 6x and the 12, right? So what is x minus 6x? Negative 5x. And what's negative 2 minus 12? Negative 14. Negative 12 minus 12. We're not multiplying here. It's just negative 2 minus 12. So it's negative 14. Now, yes. So at this step, you should, before you cross multiply, you should be looking, okay, are the denominators the same? Are they here actually? Ah, why? So this is x minus 2x plus 2. What is x squared minus 4 the same as? X plus 2x minus 2, which is that the same as our other denominator? Oh, yes. So actually here, because we have a fraction set equal to a fraction that has the same denominator, you can cancel out the denominators and just be left with the numerator. Negative 5x minus 14 is equal to x. Then you add 5 over. And divide by 6. And what does negative 14 over 6 simplify to? Negative 7/3. Now, is that something that made this undefined? Nope, so this is a reasonable solution. Any questions on this problem? Is everyone okay? I know this was a lot of information all at once. Okay.